This lesson is on right triangle trigonometry. This is section 4.1 from your book. So there are 6 trigonometric functions, and these correspond to 6 trigonometric ratios. We can also just call these trig ratios and trig functions for short. So you'll notice we have a triangle to the right. So the way that we describe the 6 trig functions is how they correspond to a triangle. Really, we're evaluating how different angles and sides in a triangle play together. So let's define some things about this triangle first. So we have a right angle, right? We have a 90-degree angle as part of our triangle. Across from our 90-degree angle, we have something called the hypotenuse. That's the long side that is across from the 90-degree angle. We also have, if we're considering an angle over here, we have an angle theta. Whatever side is next to that angle theta, we're going to call our adjacent side. I'll just abbreviate that ADJ. And across from that theta, we have our opposite side. So now that we have these parts of our triangle defined, our hypotenuse, our theta, our adjacent side, and our opposite side, we can start talking about our trig functions and the different trig ratios that we have. So sine theta can be defined as opposite over hypotenuse. Cosine theta is the same as adjacent over hypotenuse. Tangent theta is the same as opposite over adjacent. Cosecant theta, CSC theta, is the same as hypotenuse over opposite, which we can also say is the same as 1 over sine theta. So sine theta and cosecant are reciprocals to each other. We would call that a reciprocal function. So secant is the same as a hypotenuse over adjacent. And you'll notice that that is the same as 1 over cosine theta, right? Cosine theta was adjacent over hypotenuse. If we do the reciprocal of that, we get hypotenuse over adjacent. That's the same as secant theta. So secant and cosine theta are also reciprocal functions. Cotangent, you might expect, is going to be the reciprocal to tangent theta. So we have adjacent over opposite, which is equal to 1 over tangent theta. So we can also derive a couple additional relationships from these. So if we have tangent theta, that is the same as sine theta over cosine theta. And to prove that, we could take sine theta, which is opposite over hypotenuse, times it by the reciprocal. That's the same as dividing, right? So we could take hypotenuse over adjacent. You'll notice that the hypotenuses are going to cancel out. You get opposite over adjacent, which we know is equal to tangent theta from above. Similarly, cotangent theta is the same as 1 over tangent theta, so you already expect that it's going to be the same as cosine theta over sine theta, and you can do the same proof there. So let's do an example together. It says find the exact values of the 6 trig functions. There are 6, we need to find all 6, of theta. So the length of the side opposite theta is 8, the length of the side adjacent to theta is 15, and the length of the hypotenuse is 17. So we're given this triangle right here. We have theta, across from theta is 8, adjacent to theta is 15, and the hypotenuse is 17. So let's start filling this in. Sine theta is the same as opposite over hypotenuse, so that's the same as 8 over 17. Cosine theta is 15 over 17, adjacent over hypotenuse. Tangent theta is opposite over adjacent, which is 8 over 15. Cosecant theta is the same as hypotenuse over opposite, which is 17 over 8. Secant theta is 17 over 15, and cotangent theta is 15 over 8. So this might be a more clear way to notice which functions are reciprocals of each other. So there's also some special angles that happen for certain triangles that cause our sine, cosine, tangent, cosecant, secant, and cotangent to be consistent. They're always going to be the same. So if we have a sine of 30 degrees, we're always going to get 1/2. Every single time, no matter what the sides of that triangle are. The reason for that is because the ratio of the other sides of the triangle have a special relationship. So for a 30, 60, 90 triangle, when we have 30 degrees, the side opposite from the 30 degrees is going to be equal to x. The side adjacent to the 30 degrees is going to be equal to root 3 times x. The hypotenuse is equal to 2x. So that's true for any x. You could plug in 1, you could plug in 3, you could plug in 5, you could plug in 100 million thousand. Those numbers are always going to be true. That relationship is always going to be true. And for that reason, because we calculate these trig functions as ratios, of one side divided by another side, those x's are going to cancel out and we're going to get the following relationships. So really what's helpful here is to memorize the trig ratios and to understand what this triangle looks like. If you understand what the triangle looks like, then you'll always get the right answer for sine theta, cosine theta, tangent theta. 45, 45, 90 is another triangle where this works. For a 45, 45, 90 triangle, across from our 45, so opposite of our 45 degrees, we are going to have an angle that is equal, a side that is equal to x. Adjacent to our 45, we are also going to have a side that is equal to x. Our hypotenuse for that one is going to be equal to square root of 2 times x. So let's do an example for this one. Let's just prove it. So if we were to do cosine of 45, cosine is equal to what? Adjacent over hypotenuse, right? Oops, sorry about that. Adjacent over hypotenuse. So our adjacent is equal to x over root 2 times x. So our x's are going to cancel out. We have 1 over square root of 2. We're not allowed to have square roots in the bottom, so we have to multiply by square root of 2 over 2. We end up with square root of 2, and we have square root of 2 squared in the bottom, which is going to just leave us with 2. So cosine of 45 is going to equal square root of 2 over 2. What you'll notice is if you also take the sine of 45, you're also going to get square root of 2, because for opposite over hypotenuse, you still have x over square root of 2, x. So in some cases, the sides of the triangle will be provided, like we've been doing so far. So you're saying sine theta equals 5 over 8 or something like that, but not the angle. In this situation, you can solve for theta instead. So far we've been solving for whatever sine of theta is. So in this situation, you can solve using inverse trig functions. So if we were to say sine theta equals some x, we could say that the inverse of sine is equal to some theta. So the inverse of sine is not the same as 1 over sine, right? That was equal to a different function entirely. Inverse of sine works very similarly to inverse of functions. We took the inverse of a function, it was like we replaced y and x, right? For this one, we are basically replacing our theta and our x. So let's talk about how this works. And also sine, the inverse sine is just the same button on your calculator if you use second. So you'll do second sine, and that's where you'll find your sine inverse function. So use a trig function to find the measure of theta. We're given this triangle. We have a right triangle. We have theta. Adjacent to theta, we have number 11 as a side, and across from theta, opposite of theta, we have 26 as the length of our side. So we're trying to find what theta is. So we can know that we can do opposite over adjacent. That's all the information we have. So let's start there. We have tangent of theta is going to equal opposite over adjacent. We know that that opposite over adjacent, tangent theta, is equal to 26 over 11. So in order to now find theta, we need to take the inverse tangent of that 26 over 11. That is going to give us this theta. We're looking for degrees. And the answer we get when we plug that in our calculator is 67 degrees.